Okay, so now we are reviewing Unit C for your midterm exam. Unit C was all about logarithms and exponentials. So what we need there is we need our calculator. So make sure your calculator is handy for these questions. So for this, we want to evaluate log base 4 of 9 with our calculator. We need the change of base formula. So this is actually going to be log base 10 of 9 over log base 10 of 4. So if I do my calculator, log of 9 divided by log of 4, I get about 1.58, so I'm going to put 1.58. For the next one, I get log of 20 divided by log of 6. So yet again, go back to the calculator, log of 20 divided by log of 6. And so I get about 1.67. Next, log of 1.4 divided by log of 6. Now the cool thing about this is you can actually do natural log as well. So natural log of 1.4 divided by natural log of 6. And I'll give you the same answer as log. So 0.188. Say that. Here, this is actually just what it is. So we can put log 3.7. I've seen people try and use change of base formula for this, but don't forget, if you do log base 10 of 10, because this is base 10, log base 10 of 10 is just 1, so you just divide this by 1. So it's not too important. So we do 0.568. And I guess if I want to be consistent with this, I should make these about equal to. And so that's it. Change of base formula. Know it. Know how to use your calculator. We want to condense these expressions, and we got some variables here. So A, B, and C. So this is log base 2 of A plus log base 2 of B plus 5. So when we are condensing, we want to use the power property first. So this is log base 2 of A plus log base 2 of B plus log base 2 of C to the 5th. Remember, we make this 5 a power, and so now we have log base 2 of A, B, C to the 5th. Next up, we look for any coefficients, and we got one, so we do log base 2 of 7 plus log base 2 of 3 plus log base 2 of 5 to the 6th. So this becomes log base 2 of 7 times 3 times 5 to the 6th. Well, that's going to be 21 times 5 to the 6th, which is 3281.25. So log base 2 of, I already forgot the number. It's so obnoxiously big. 3281.25. Next up, we are subtracting, but yet again, we're going to do our quotient property, or sorry, power property first. So log base 8 of A to the 30th minus log base 8 of B to the 5th. And then we use our quotient property. So this is log base 8 of A to the 30th over B to the 5th. Next up, log base 9 of x to the 3rd plus log base 9 of y to the 15th. So we get log base 9 of x to the 3rd, y to the 15th. Put that in parentheses so it shows I'm taking the log of the whole thing. All right, this next one, ooh, this looks tricky. Don't be confused too much with this. So we're going to actually, so I can rewrite this. So 2 log base 9 of c plus 1/3 log base 9 of a. That's right. Whenever we're dividing by 3, it's the same as multiplying by a third. So here this is going to be log base 9 of c squared plus log base 9 of a to the 1/3. So this is just log base 9 of c squared a to the 1/3. Next up, log base 6 of a to the 6th minus log base 6 of b to the 4th. So we get log base 6 of a to the 6th over b to the 4th. And that is our answer there. All right, next up we want to expand. So when we expand, we need to watch out for a few things. So here, this exponent, I'm actually going to distribute this in first. There are a few different ways to handle this, but if I distribute this exponent, oops, it's y to the 4th to the 3rd. Exponent property is coming in play, so that's y to the 12th. This a quotient, so I'm going to get log base 2 of x to the 3rd minus log base 2 of y to the 12th. And so this is just 3 times log base 2 of x minus 12 times log base 2 of y. And so that is our answer. Same thing with the next one here. I'm going to have log base 2 of x to the 24th over y to the 4th. So this is log base 2 of x to the 24th minus log base 2 of y to the 4th. And so this is going to be 24 times log base 2 of x minus 4 times log base 2 of y. So there are 3 properties with these: quotient property, product property, and power property. And all you're doing is just changing between the 3. So with these 2, we had power property last after we do the quotient property. So next up, this is all just product property. So this is tedious. Log base 7 of x plus log base 7 of y plus log base 7 of z to the 4th. But of course that z to the 4th can come down, so if I can just copy this, save myself the time, that'd be nice if we could do that on the test. The first 2 terms stay the same, but this has an exponent, so we get 4 times log base 7 of z. And that is our answer in quite sloppy fashion. Yeah, this board is not the best that I write on. Oh well, no product placements for me. So here we're going to have log base 4 of, that is a 4. See, this thing is a mess. Log base 4 of 2 to the 5th plus log base 4 of 3 to the 5th. So this actually becomes 5 log base 4 of 2 plus 5 log base 4 of 3. So actually 2 is really 4 to the 1/2 power. So what I could do here, and again I'll probably just copy and paste this so I don't confuse anybody with what I'm doing next. What we could do is we could rewrite 2 as 4 to the 1/2. Now why would we want to do that? Well, look at what I have. I have now log base 4 of 4, which is 1. So I get 5/2 plus 5 times log base 4 of 3. So anything you can reduce using those basic properties, make sure you watch out for. Next up here, we have 2. Yeah, so this one is not going to reduce in quite the same way. So I'm going to do log base 2 of 5 squared over 12 to the 4th. And so this is log base 2 of 5 squared minus log base 2 of 12 to the 4th. And then we bring down the power, so it's 2 times log base 2 of 5 minus 4 log base 2 of 12. Now, if you actually did 12 squared, so you did 25 over, this would be 144 squared, you'd have to reduce it again. So this is actually the best way to do it, because now this log is reduced as much as we can, and we have these coefficients. So watch out for little tricks like that. Number 16, we have natural log of z squared times x to the 1/2. Remember, square root is the 1/2 power. So I'm running out of room here, but we're going to separate this. So we get natural log of z squared plus natural log of x to the 1/2. So we actually get 2 times the natural log of z plus 1/2 times the natural log of x. And that does it for us there. All right, now we want to solve these equations. So remember, if it's an exponential equation, we want to make it a log. So these 4 questions are exponential equations. So I'm going to take the log. So here, I'm going to add 8.6 to both sides. So I get 9 to the b minus 7 power is equal to 88.6. And then I'm going to take the log. So we rewrite this. So we get log base 9 of 88.6 is equal to b minus 7. So what we're going to do, going back to our calculator, so log of 88.6 divided by log, what was the base, 9? We get this, and then all we have to do is add that 7, and we get 9.04. So b is equal to 9.04. That's our answer. And we can check by plugging this back in, getting a rough approximation of, should get about 82. For next up, we have e to the negative 3p is equal to 87 because we add 2 to both sides. This is log base e, but what we're going to do, and I'll write this out, we do natural log of 87 because log base e is natural log. And we're going to take that and divide that by negative 3. So we get natural log of 87. Divide that answer by negative 3. And we get negative 1.49. So p is equal to negative 1.49. Next up, I add 5, so I get 20 to the n minus 6 power is equal to 69. So this is going to be the log of 69 divided by the log of 20, which I actually don't think I wrote down. I think I just jumped right to this. So this is going to be log of 20, log base 20 of 69 is equal to n minus 6. And that gives us 1.433. And then we are going to add 6. So 7.41 is going to be n. Next up, we add 8. So we get 3 to the n minus 5.5 is equal to 50. We're going to take the log base 3 of 50 is equal to n minus 5.5. So yet again, we do the log of 50 divided by the log of 3. And we are going to add 5.5 to get 9.06. And of course, in typical fashion, I finished all these and then I just glanced at the instructions. I rounded to the nearest thousandth, not 10,000th. Oops. So 2 decimal places is fine. As long as you're not rounding to the tenths or the whole number, you're okay. So we want to solve these equations, so we have to use a little bit of our properties here. So here, I'm going to use my quotient property, so I get log base 3 of x over x plus 4 is equal to log base 3 of 67. Well, wait, the log bases are the same, so that means that x divided by x plus 4 is equal to 67. I can multiply both sides by x plus 4, so I get x is equal to 67x plus whatever 67 times 4 is. 67 times 4 is 268. I really ran out of room on this one. So we can combine our like terms, so we get negative 66x is equal to 268. So x is equal to negative 4.06. So let me get that. Right. Next one. Yet again, we see this common log, so we're going to do log base 5 of x divided by x plus 2. My computer's really lagging here for some reason. And because this is a log, I'm going to have to make it an exponential. So this becomes 5 to the third is equal to x divided by x plus 2. So sort of the same thing. This is actually 125. So this gives us 125x plus 250 is equal to 1x. And so that means 250 is equal to negative 124x. So 250 divided by negative 124 is going to give me x. So x is equal to negative 2.02. And that is our answer. Next up, combine the logs. So we get log base 9 of 7 over negative 5x is equal to 1. Rewrite this as an exponential, so this is 9 to the first is equal to negative 7 over 5x. So this is, I could say this is negative 45x is equal to 7. So x is equal to 7 divided by 45, or negative 7 divided by 45, which is negative 0.156. And we got one more here. Pretty much going to be similar to number 21. I can combine these, so this is log base 6 of 16x is equal to log base 6 of 9. Because the bases are the same, the logs are the same. So we get 16x is equal to 9. So 9 divided by 16. So I could leave that as 9 over 16 actually. If you want to make that decimal, that's 0.5625. Whatever, I don't care about that one. We're using decimals for everything else, so if you made a decimal here, I wouldn't be my usual grumpy self if you left it as a fraction. Or you made it a decimal instead of a fraction. Yeah, so that's it. So make sure that you know that we're changing logs to exponentials, exponentials to logs in order to solve these. Look at that, there's all the answers, so hopefully I did all right with them. I don't know, number 7, did I do that right? Yeah. So a lot of work, a lot of tedious work. It can be confusing. So this was probably the hardest unit that we had for the midterm. So make sure that when you're studying, you dedicate the most time to this. Questions on here are more challenging, but they'll be good preparation for your exam. Your exam questions won't be as challenging. But do make sure that you ask questions and keep up the good work.